Hey everybody, this is Larry. This is January 6th in the new year 2023. Let's do a problem that I haven't done before. Let's just do a random one. It doesn't matter what difficulty, though it looks like it'll probably be a medium. So let's go. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem. And finally, we have a premium problem. If you haven't, or if you don't have premium, feel free to follow along and just read along me. I haven't seen this one yet, so it'll be fun for all of us. 2378, choose edges to maximize score in a tree. Okay, so you're given a weighted tree where end nodes, you have nodes, okay, you have a rooted at 0, fine. You have a 2D array of edges where edges of I is your par rate or parent and the rate. You could just spell out parent. Why did they say par? Okay. Choose some edges from the tree such that no chosen edges are adjacent and the sum of the weights is maximized. Okay. Okay. I think the key thing to problems like this is really try to distill what the definitions mean. For me, the first thing to think about is what you're allowed to not choose any edges. Okay, fine. Okay. Yeah, I mean, what I was gonna say is what does the edges are adjacent mean, right? Of course, there's the actual definition, but what does that mean when it comes to a tree, right? Because maybe in a general graph, there's a different thing, but for a tree, maybe there's a property that we may have to think about. And I don't know. Just to be clear, I don't know this quite yet, so we'll think about it, right? And the way to think about it maybe is just to explore some small examples. And usually I love writing it on a notepad or something like this and drawing it out by my hand. I'm going to try to do it on screen. Usually, and if you watch this channel, you know that I do a lot of ASCII art as well. But for a tree, that's probably a little bit different. So this is the part of where I'm trying to explore the properties of this problem and try to figure out literally, well, now what does it mean to have an adjacent thing, right? All right, let me set up the thing because I've been talking and I forgot what I was doing or trying to do. Okay. Okay, so basically, let's say we have a tree, and I'm just thinking about all the cases that we have to consider, right? Meaning that, okay, let's say we have, and this is not a binary tree. I think they tell you that kind of, and it's even in one of the examples. Okay, so let's say, like, does it make sense to think about it in terms of nodes? Not necessarily. Well, I mean, we can definitely figure it out. I think it's just recursion. Basically, you do two recursion. I mean, you could also think about it as memorization, maybe, but you could pre-calculate it in 2 steps, right? Meaning that given a rooted, the recursion, and is this a medium or hard? I didn't even notice. A medium, wow, that's kind of hard for a medium. Maybe not, I don't know. But the idea here is that for each node, we either have an edge that we used or we don't have an edge that we used, right? Meaning that, let's say this, let me choose a different color, hang on. Let's say we chose this X edge, that means that we cannot use these edges, right? So then this one in the recursion will have some f of, I don't know, the node, and then cannot be used, right? Like false. And then that will allow us to kind of go down and then calculate stuff, the maximum score, given that we cannot use these edges, which will be just the sum of these nodes, right? Where they can use the edges, right? So now it'll be f of x, maybe 2, say, and then true, because now you can use any edges going from the child, from that node. That's basically what we will do. Okay, I think we're good. I think the easy way is to do it with memorization, but I'm not going to do it with memorization. What is this? Oh, okay. But I'm not going to do it with memorization. I'm going to do it with pre-calculation, and then in a way, it will be dynamic programming. I'll go over it in a second. So basically, we want two results, right? We want max score, choosing child edge, choosing edge maybe, I don't know, right? And okay, so y is equal to the length of the number of edges, and then n is just, well, it's a tree, so z minus 1. And then now let's actually take some time to oh wait, this is parent and weight, right? Not my usual edges. So then now, and I like to kind of set up the as a children edge list. So then now y of p append I guess IW, but we didn't do the I until now. Okay, and this is -1. Okay, fine. But we don't have to care about the -1, right? Probably not. Okay. If p is equal to -1, continue. Oops. Okay, so then now we just get, say, 0 times n, and then max scores not choosing edge is equal to also 0 times n. Right? That's just the default setting. And then now we just use two recursion to be, okay, calculate the max score that we can choose from an edge, right? Is this the best way to do it? Let me think about it for a second. Maybe I think I have to do it the other direction first. Okay, so yeah, so let's just say it's so much easier with memorization. Maybe I should have done it that way. But anyway, let's just say get max score not choosing edge, right, of node, the current node, and then this basically gets the max score No, I guess I have to do it with memorization. I think this is too hard to do without it. Okay. Yeah. Yeah, but anyway, this gets max score of the subtree at node, while no ability to choose an edge, right? And of course, the way to do this is going to be for, if you think about what that means, right, is that we're just going to take the sum of all the nodes of the children, because we're not choosing any of the edges, so it's okay to choose the sum. So basically, what we're going to get is going to be something like this. For v in e of node, total we added to get max score choosing edge, because now we're skipping this edge, is what we're saying, because we're connected to a parent, because we're choosing the edge, or when we cannot use this edge, but that means that the child can choose edges, because now it's free to do whatever they like. So yeah, so this is going to be we, and then just return total. I'll go over the memorization part a little bit later, I suppose. So then the max score choosing edges, what are we doing, right? So basically now, how do I phrase this in a good way? So basically now we have all these children and we can choose an edge. And in fact, we want to choose one edge, right? So then now, sorry, I want to be precise about this. For each of those children, basically we want to choose one, and then the rest of them is that they're able to choose an edge, right? Because basically, if you think about the visualization, I hope I took it off. You can think of, let me just bring it up real quick. Basically, what you're thinking of, or what I'm thinking of anyway, if I could find my pen thingy. Where did my pen thingy go? Oh, why is it? Why are you over here? Is that so? The case that we're thinking of is that now, let's say we have, with a lot of thingy, right? So let's say we chose this one, right? What does that mean? Well, that means that this node is going to be, well, you can't choose any of those edges. But then here on the other ones, on the other child, then you can easily choose those edges, right? And then the idea now is trying to, if you do that very naively, it's going to be n squared. I think that's, because, you choose one and then you calculate all the other ones. But then the idea is that now you can reuse a lot of this. And so we should, right? The idea is that, okay, so then here, the idea is going to be, okay, we actually get the max score choosing edge of V for the child. And then here, this is maybe the hard part, or maybe not the hard part, but, well, it is harder for me anyway. Maybe it's easier for you, but I feel like it should be easier. Just, I don't know, my brain is not working. But yeah, so this is the total. Let me rename this variable. Total or edges, right? And then now the difference is just that if we choose that one, then for we in Yi node, and let's just say best is equal to 0, then what we want is maximize. So total or edges minus get max score choosing edge of V. Basically, this now gets the score of everything minus choosing this one. And then now we want to add this to get max score not choosing edge of V, right? And then we return best. Okay. And we have to do the memorization now, I suppose, because this is just exponential, right? We could probably do it, but yeah. Get max score choosing edge at, I think 0. Is that what they say? Like they don't. Yeah, is rooted at 0, right? And this should give us the right answer. Oh, collections. What did I type? Okay, that's unfortunate. Oh, I think I didn't choose the edge. So here, now that we choose the edge, we add the weight. Whoops. Also, I forget to do this. I guess for here it doesn't really matter. But this one we have to do. Okay, so this one's good for this one, but that's because it's choosing one edge. And this one I'm wrong. Okay, so I get 5, but then let me think about this. Maybe I'm missing an edge case. Edge, yeah, okay. Okay, let's just print things out, I suppose. Node best. Because it should print 2. Node 2 should have 6, or at least anything. Okay, so 2 has 6, right? And then the total of all edges. This is returning 0 is fine, but this one returning 0 is not fine, right? Because this should be, this should go to the 2, right? Unless I did it wrong, and this is why. It's just doing some weird things. Okay. Wow. Okay. Fine, Larry. Because I guess it was passing in the tuple. What a silly mistake. Okay. So now we have a good answer, but this is going to time out because in this particular case, we actually even call the same function twice. But even if not, we call, branches out 3 times in each call. Well, actually more than 3 times, just 3 times for each node, right? So what we want to do is just reduce that, and we do it by, with memorization, right? So yeah, let's just say this is the cache. And then the way that I always do it, as you know, and this is just for teaching purposes, I know that you could put in a add cache decorator. Yeah, and then now we can just, do the normal thing. And then if, is it this one? I think so. Right? All right, and then this one as well. So I'm a little quiet. There's really not much to say. I'm just typing out the dynamic programming part. Oh, because of -1, maybe? Why would it? Each of these has a thing, right? It's either that or I forgot to. And that, well, I mean, that would be why it, like if I had this earlier, it would have caught the silly mess. But, why is that? Times n, right? Oh, I'm wrong about the edge because they have this one for some reason. The edges is not this. This is okay. Fine. That's kind of silly, actually. Uh-oh. Oh, wrong answer. I didn't expect that. Oh, there's negative numbers. Okay, fine. Didn't expect negative. I guess I just didn't look at the input really carefully, to be honest. I mean, okay. Let's. I mean, it just changes the base case, and I think that's mostly why. Yeah, and basically all it does is we can also set this is equal to total or edges, and it just means that we don't choose any of the edges, right? Did we have the case? I missed it. Yeah, and that should fix it. I don't think this changes. Yeah, because we just don't pick it. Okay. I didn't. I just didn't look at the constraints carefully. Yeah. Yeah, I mean, overall, not a bad problem. Kind of annoying. Some parts of it is annoying, and I really did. Okay, it is part of example 2. It just didn't change the answer, so I have nothing to say. I just didn't notice that in chat. That would change my base case. But yeah, so what's the complexity here, right? Well, we only call this one. There's n different inputs, and each of those would take over 1 time, kind of. On average, because that's the number of edges that are in total of these things. So that means that if you sum up, maybe node 1 with node 0 would call it 3 times, node 1 call it twice, ... But the sum of those edges will be only O of n because this is a tree. So yeah, so in that sense, even though there's a for loop inside, this is going to be amortized over one across all the possible inputs. So this is going to be linear time, linear space, and the same for this function as well. Everything is O of one. You can say that, like I said, there's two for loops, but for each edge, and there's only n edges for all the nodes in summation, right? So that's why you can do linear time, linear space. This is kind of a tricky question. I don't know if this is a I mean, medium is probably an okay difficulty for it, but honestly, it's a kind of a harder medium if you haven't really thought about stuff like this. But yeah, especially if you have to write out the DP manually. Oh man, did I not remove this? I just realized. Okay, let me Oh, that's really sad. That covers all the code. Sorry, friends. I just realized that my thingy is on the screen. Silly things happen, but I will show you the code and what I was saying. I'm really sad about it. Sorry, friends. Hit the like button if you want to give me some support. Oh my. Okay, this is a tricky problem, but yeah. But what I was saying, what did I get to? So I was thinking. I think I brought the drawing up when I was going over this function to get max score choosing edge, and I was just saying that. Okay, so in order to not make it n square, we sorry friends, caught me off guard. In order to not make it n square, we basically get the delta, right, and to make it over one for each calculation. So basically, we get all the edges if we don't choose any of them, and then the score of us choosing it is just substituting it for choosing the edge or not choosing the edge, and with choosing the edge plus W for the weight of the edge, and that's pretty much it. Yeah, so that would give you. So this gives us the score of if we chose this edge, and then of that drawing that we just saw. And then I sorry friends, but yeah, and then I just did add the memorization thing that I always do, because you can see that there's, like I said, it calls these functions like 2-3 times or even more depending how you want to say it, because of the branching. So that's going to, so that's why we added in the memorization, which we did here. You didn't see me painfully doing it, but now that you see it, I guess. Sorry friends. Yeah, and as I said, just to kind of go over it a little bit more, because I highlighted it a little bit, the reason why this is only linear time in total is because even though there's there's a for loop here, as I said, the summation of all the edges, there are only n edges in total, right? So that means that this is only going to make n edges no matter how many, given n nodes, it's going to call n edges, even though they don't call it all at the same time. This would actually give us a bad performance if we're not caching or memorizing. But because we don't have to worry about all this stuff. So yeah. And the same logic here as well. So this is linear time, linear space. Let me show you the top of the code. Yeah, this is to set up the edges. And I also, just to kind of be, I think there's one more thing. Well, let me go over the 2 bugs that I had because you didn't see me going over the code because I was being a dum-dum. One was that I was doing for V and G of node, so I think it was just recursioning. It was recursing on the tuple, so that's why it was giving me zeros, and I fixed that. And then the other one was that, let me just pull that up. I just didn't know that there was going to be a negative, I didn't know there was going to be a negative rate, so I just kind of, my base case was wrong because I forced, the way that I did my base case, before it was 0. So basically you're forced to choose an edge, meaning one of the answers. But then when I, wanting to fix it, when I saw the negative edge, I was like, okay, you don't have to take every edge. Then here, this now represents a new base case of not taking any edge from this current node. Cool. Sorry, friends. But I think that's all I have for this one. Let me know what you think. This is the top of the code. This is the bottom of the code. Hope you stayed till the end. or fast forward to it or whatever. But that's all I have. Have a great weekend, everybody. Stay good, stay healthy to good mental health. I'll see y'all later and take care. Bye bye.